Southern Ocean. The Southern Ocean holds a staggering 20.3 million square kilometers of water. This is an area so large it is hard to imagine. It makes up nearly 6% of the Earth's total ocean surface. This vast, cold body of water surrounds the entire continent of Antarctica. It is the only ocean that flows completely around a continent without being blocked by land. This unique feature makes it a critical part of our planet's systems. The sheer volume of water it moves is immense. The main current carries more than 100 times the flow of all the world's rivers combined. This simple fact begins to tell the story of its power and global importance. It is a world of extremes, defined by huge numbers and powerful forces. Understanding this ocean begins with its size. It is the fourth largest of the world's 5 oceans, larger than the entire continent of Antarctica that it encircles. The Southern Ocean is a special body of water. For a long time, geographers did not agree on its name or its borders. It was often seen simply as the southern parts of the Atlantic, Pacific, Indian Oceans. However, scientists noticed that the water around Antarctica was very different. In the year 2000, the International Hydrographic Organization officially recognized it as the Fifth Ocean. Its northern boundary is defined by a line of latitude, 60 degrees south. South of this imaginary line, the ocean's characteristics change dramatically. The water becomes colder, less salty, flows in a distinct pattern. This recognition helps us focus on its unique features and its importance. This ocean is a place of mixing. At the heart of the Southern Ocean is a powerful and relentless force, the Antarctic Circumpolar Current, often called the ACC. This is the largest and strongest ocean current on our planet. It flows continuously from west to east, circling the entire continent of Antarctica. The amount of water it moves is almost beyond comprehension. Every second, it transports between 135 million cubic meters and 145 million cubic meters. This is more than 100 times the flow of all the rivers in the world put together. This massive movement of water acts like a giant flywheel for the Earth's climate system, storing and transporting heat, salt, and nutrients around the globe. The power of the ACC is generated by the strong, consistent westerly winds that blow across the Southern Ocean. Roaring 40s, furious 50s, screaming 60s. With no large landmasses to block their path, these winds push the surface of the ocean relentlessly, creating the massive eastward flow of the current. The word circumpolar provides the key to understanding the Antarctic Circumpolar Current. It simply means around the pole. The ACC is the only major ocean current that flows all the way around the globe without being obstructed by a continent. In the northern hemisphere, landmasses like North America, Eurasia, block any potential for a similar current. But in the south, there is a wide-open passage of ocean that encircles Antarctica. This unique geography allows the westerly winds to drive the water in a continuous, uninterrupted loop. This continuous flow is made possible by the Drake Passage, located between the southern tip of South America and the northern tip of the Antarctic Peninsula. It is the narrowest point in the Southern Ocean, about 800 kilometers wide. Its opening millions of years ago initiated the ACC, thermally isolating Antarctica and fostering its massive ice sheet. The current's circular path creates fronts, subtropical to the north and polar closer to Antarctica, that meander and define distinct habitats. The Southern Ocean is defined by its coldness. Water temperatures near the surface are consistently low, often hovering near the freezing point of seawater, which is about -1.8 degrees Celsius, 28.7 degrees Fahrenheit. Even in the summer, the water rarely gets much warmer than a few degrees above freezing. This extreme cold is a fundamental characteristic of the region. It influences everything from the type of animals that can survive here to the way water circulates. The cold, dense water created in this region is a key driver of global ocean circulation, as it sinks and spreads northward along the ocean floor, carrying oxygen to the deep sea. A defining feature of this cold environment is sea ice. Each year, the Southern Ocean goes through a dramatic transformation. During the autumn and winter months, vast areas of the ocean's surface freeze, forming a layer of sea ice that expands outward from the Antarctic continent. At its maximum in September, it can cover nearly 19 million square kilometers, Despite the extreme cold and long winter darkness, the Southern Ocean is teeming with life. The marine ecosystem here is incredibly rich and productive, especially during the summer months. The foundation of this entire ecosystem is built on something very small: phytoplankton. These are microscopic, single-celled plants that float in the sunlit upper layers of the ocean, creating food through photosynthesis. During the Antarctic summer, when there is continuous daylight, these tiny organisms bloom in enormous quantities, turning vast areas of the ocean a greenish color. Upwelling brings deep, nutrient-rich water, nitrates, phosphates, silicates, to the surface. This seasonal boom forms the base of the Antarctic food web, providing the energy that sustains all other life. The food web is relatively simple, but highly efficient: tiny plants to zooplankton to great predators. In the grand and powerful Southern Ocean, one of the most important animals is surprisingly small. This animal is the Antarctic krill, a shrimp-like crustacean that grows to about 6 centimeters in length. Despite their small size, they are the central pillar of the entire Antarctic food web. They gather in enormous swarms, sometimes stretching for kilometers and containing billions of individuals. Their total biomass is among the largest of any species on Earth. As primary consumers, they convert phytoplankton into energy for larger animals. Main food sources: whales, seals, penguins, squid, fish. The health and abundance of krill affect almost every larger Antarctic animal. Their life cycle is tied to sea ice. In winter, krill feed on algae under the ice, which offers food and refuge. Krill are also fished for aquaculture feed, fish bait, and omega-3 supplements, so CCAMLR sets strict catch limits. The challenge: balance human needs with ecosystem needs, ensuring the tiny heart of the Southern Ocean keeps beating. The Southern Ocean is a critical feeding ground for some of the largest animals on Earth, the great whales. After decades of protection, many whale populations are slowly recovering and returning to these rich waters. In summer, baleen whales migrate thousands of kilometers to feast on krill. Blue whale, fin whale, humpback whale, drawn by dense swarms of krill. A single blue whale can consume up to 4 tons in a day. These gentle giants filter krill using baleen plates, building fat reserves for long migrations to breed. Toothed whales like orcas hunt in sophisticated pods, targeting seals and even minke whales and toothfish. Weddell seals live further south than any other mammal, diving over an hour and rasping breathing holes in the ice. Crab-eater seals, ironically named, filter krill with multi-lobed teeth and are the most abundant seals. Leopard seals are formidable predators, while giant elephant seal bulls battle for harems on subantarctic islands. When many people think of Antarctica, the first animal that comes to mind is the penguin. Several species are uniquely adapted to the harsh conditions of the Southern Ocean. The emperor penguin breeds in winter. Males endure darkness and blizzards, incubating a single egg on their feet. Adelie and Gentoo penguins nest on ice-free rocks, raising chicks on krill and fish. Dense, waterproof feathers insulate. Stiff wings evolve into powerful flippers for incredible underwater agility. Vast colonies enrich the land with nutrients, supporting patches of mosses and lichens. The wandering albatross, wingspan up to 3.5 meters, masters dynamics soaring across the westerlies. Petrels, skuas, and terns complete the aerial realm, from scavengers to record migrations. Beyond the life it supports, the Southern Ocean has many other important physical characteristics. The salinity of the water varies. Near melting sea ice, the surface is fresher. Where sea ice forms, water becomes saltier and denser. The seafloor hosts ridges and deep basins that steer currents and mixing. The water is layered: cold, dense water below, slightly warmer mixed water above, crucial for storing heat and carbon. By absorbing vast amounts of heat and carbon dioxide, it acts as a critical buffer against climate change, with cold waters dissolving CO2 that circulation transports into the deep. This helps slow global warming, locking carbon away for centuries. But absorption makes the ocean more acidic, threatening shell-forming organisms, plankton, and krill. Past overfishing depleted some species. Today, the krill fishery demands careful management. Pollution rides currents here. Microplastics are found in the water, the sea ice, and in Antarctic animals. Growing shipping and tourism bring risks of oil spills and invasive species. Still, there is strong international commitment to protect this unique environment. Marine protected areas, such as the Ross Sea, conserve key habitats. Through cooperation and careful management, we can preserve the health and wonder of this vital, icy ocean for the future.